Okay. So, good morning, everyone. Uh, I welcome you all for the today's webinar on unsupervised deep learning architecture, that is generative adversarial learning. First of all, I would like to, it takes me very immense pleasure to welcome our today's speaker, uh, Mr. Rishabh Dhenkawat and Mr. Utkarsh Chaurasia, sir. Both of them, they are research scholar at NIT Hamirpur, as well as they are a artificial intelligence and machine learning developer for the various renowned companies like Google and all. So it gives me very immense pleasure to welcome you all again for this one day's webinar on unsupervised deep learning architecture GAN. Uh, First of all, I will introduce our today's guest of honor, Mr. Rishabh Dhenkawat, sir. Before that, I would request all the participants that please keep your mic mute and please turn off your camera during the session. If you have any doubts, we have kept the last 10 minutes of this session for the question and answer session. So both Rishabh sir and Utkarsh sir, they will take your questions in last 10 minutes. Okay, so without wasting time, I will introduce our today's first speaker, uh, Mr. Rishabh Dhenkawat sir. So Rishabh sir is a MTech research scholar at NIT Hamirpur. He has developed so many projects, to name a few. Drishti, a deep learning project which can control a person just like a remote control boat. And this project was funded by NIT Hamirpur. He has also developed a cloud e-voting system which was judged by Election Commission of India, GitHub, and IBM. So it is a cloud deployed supported e-voting platform. Then he has also developed a semiotic search engine S3E, which is a platform for image search powered by the TensorFlow deep learning. He has also developed a NLP search engine with a graph database, which is an artificial optimized search engine based on graph database made with the NLTK library in Python. He has also developed the Cordbot, a boat work with servo motors and have a 12 degree of freedom using computer vision. So in which they have used the Raspberry Pi as a microcontroller, PyCam for collecting live frames, so on and so forth. He made an ML-based real-time human temperature mask, analyzing a user's body temperature using ML data analytics technique that will enable us to monitor and analyze that how much user is prone to disease like a common cold, viral infection, flu, malaria, so on. He's a executive member of Society for Promotion of Electronics Culture. He's also a member of Robotics Society. Uh, Coming at his achievement, believe me, it will take another 10 minutes to read his complete profile. Uh, so I'll just conclude with his achievement. He's a winner of Smart India Hackathon 2020 under AICT, winner of Lost Port India Challenge among 3,000 teams by GitHub, IBM, Times of India, selected in top 100 teams among 18,000 in IICDC by Government of India for Drishti, selected in top 100 team in KPIT Sparkle among 4,000 teams, winner of Hack Overflow at Chandigarh University for Drishti, winner of Electron at NIT Hamirpur for Drishti. He is honored with the best technical team at Hack 4.0 for Codebot. He was also got the scholarship for the from the Department of Science and Technology, Government of India for the best innovation idea, and he hold the second position in this. So his interest includes machine learning, deep learning, data structure, uh, artificial intelligence, and so on. Right. So I welcome Rishabh sir. Sir, I welcome both of you on behalf
Thank
of
you, sir. Thank you,
Maratha
sir.
Vidya
Thanks a lot
Prasarak,
for the introduction.
yeah, Maratha Vidya Prasarak Samaj, KPT College of Engineering, Nasik. I would like to introduce, I will take another 2 minutes to introduce our second keynote speaker, Mr. Utkarsh Chaurasia, sir. I really feel proud that to introduce himself. He's a research student at Washington University, USA. He's a founder of Oculoscience Private Limited. He's a Smart India Hackathon 2020 winner. He's a member of Robotics Society NIT Hamirpur. He's also a member of Microsoft Student Partner, and he's a member of JST, that is Japan Secura Science. Okay, so talking about him, he's an artificial intelligence enthusiast with the in-depth knowledge of machine learning, deep learning algorithms, comprehensive knowledge of primary development languages and programming skill, knowledge of sensors and microcontroller. He has a great experience and rich experience of presentation and communicating with the public. So presently, he's a member of Sakura Science Club since June 2017 to present. He's a member of this body, professional body. So with this, I would like to first hand over to Sir, who is going to start first.
I will be starting first. Yeah.
Okay, okay. So, sir, over to you. Rishabh, sir, over to you.
Yeah. Yeah. Okay. So first of all, thank you, Nitin sir, for this wonderful introduction, and I feel privileged to be the part of this talk, and I welcome everyone. That, and I also thankful to everyone who spared their time to join this talk. So without wasting any time, as we are going to share you with some kind of opportunities also, and how you can start with your career in data science and machine learning, and how you can participate in the competition, and that will be taken by the Utkarsh. He will also will be sharing the research opportunities and his experience in doing research opportunities in USA too. Without wasting any time, sir, can I share my screen?
Yes, sir, you can share your screen.
Yeah.
I just stopped presenting. Yeah. Sir, over to you.
Okay. Just oh, is my screen visible?
Not yet, not yet.
Not yet.
Just hold. It's visible now. It's visible.
It's visible now?
Yeah.
Hmm. So am I visible to all? Yeah, is my screen visible? Presentation is visible to all?
Yes, sir, you are visible and presentation is also visible. You can
Yeah.
continue, sir.
So I just want to check that everyone is able to write on the chat or not. Like if they can write yes, yes, yes. Uh, it will be good that I can
Yes.
communicate with the chat. So whatever the answers I will be, what the questions I will be taking, please use the uh, please use your chat option. Yeah. Yeah. Okay. Thank you. Yeah. Okay. Okay. So everyone is able to write. Okay. Okay. That's great. Okay. So our today's session will be on generative adversarial network. So as sir already told you about you may be a bit information about generative adversarial network. So first of all, I would like to introduce myself as sir. I already told you introduce. So I was also a research and development in yeah, I was also in research and development team in Striker, and I have been for 1.5 years. I have been with data science in data science team at Pharmacy too. So I have a bit industrial experience and research experience both. So let me start with, as I think you all are in final year right now. in which year you are? You guys are? Okay. So sir told me that everyone is in final year. So without wasting any time, so I will be continuing the session by keeping in mind that you guys already have some prior knowledge of about coding in AI. Okay. So without wasting any time, so can you tell me a bit about what is AI and what is AI to you? You can write in the chat box just a simple line that how you analyze AI, how you take AI in your daily life. Yeah, you guys write in the chat box.
Yes. Uh, Dear students,
Yeah.
please, you can type your response in the chat box. And please reply, be interactive.
Okay. So missing AI is artificial. I'm just asking a small one line that what is AI for you? Yeah, I think you guys are a bit hesitating. Okay. Okay. So what is like you guys are in final years and sir told me that he already taught you about many kinds of deep learning models and CNN models. So what is deep learning for you? Like how do you understand? Sir, are they able to unmute themselves?
Yes.
Like, yeah.
Yeah. Those.
Okay. So okay, one of you can unmute yourself and tell me that how much you know about deep learning and some and stuff. Okay, yeah.
Hello.
Chapter.
Hello.
Okay, yeah.
Uh, so our cover with mostly with basic convolutional layer, convolutional neural networks. So we did basic image classification and then autoencoders and stuff like that. Our syllabus mostly consists of that.
Oh, okay, that's great. That's great. Thank you. And what was your name?
My name is Madhusudan Patil.
Yeah. Okay, Madhusudan. Thanks, Madhusudan. This is wonderful. I think you guys already know about deep learning. Okay, so all have heard about CNN and various deep learning architectures. So today, what we are going to do is and what do you know about like they are supervised or unsupervised? Can anyone tell me like various CNN architecture when I talk about CNN, are they supervised or unsupervised? And what is unsupervised and unsupervised to you? Okay, Nikita is saying deep learning is sub part of IO. Okay, right, good. Can anyone tell me is CNN a supervised thing or unsupervised model? How you like which CNN you trained in your final year or third year? Okay, supervised working on labeled data set. Okay, Zulfin say good. Okay. Okay. So yeah, I got the idea that you guys already have a good prior knowledge of CNN and machine learning architectures. Okay, supervised. Okay. So you ever thought like how we can like these with CNN we are having a particular kind of label data set. If I'm not having a label data set, that how we will be treating the models, how we are going to take that further. Okay, so this thing today we will be covering. Okay, so next thing I just want to show you that how okay. So what the thing is, why we are doing this in our why we are taking how AI is impacting our life and how these things are impacting life. You deploy CNN, you deploy various machine learning supervised and supervised model. Like that, what is the use is in your daily life? Have you ever tried to make something with these kinds of models, and have you ever incorporated those in your real life? Have you ever tried? So let me show you some kinds of videos which me and Utkar build some kind of software since our first year. So let me show you one small project. So to make the thing more sense. So this is one of the Arduino project, simple Arduino project we made in our first year. So this is a bulb. You heard about Arduino? Have you heard about Arduino? You guys just replied fast because we need to take the session a bit.
Yes, yes.
Yeah.
Yes, sir. They have
Okay.
already studied IoT in third year.
Yeah. Okay. Great. That's great. That's great. If you have studied IoT, so these are the kinds of softwares IoT. Like IoT is a good domain to deploy your basic machine learning architectures in real life. So we have made IoT. We are doing IoT since our first year. So this was the quad bot, which sir has shared that this was the quad bot we made in our second year. So this was a basic quad bot which has incorporated computer vision. So it is recognizing the face and various kinds of object in front of them. So these are the real life applications which motivate us to make the things workable, like to make the use of AI in a proper way, and how you can impact the society in a real manner. So these are the small basic project, not that much big, that you can build in your daily life also. You like home automation, so we also did the home automation. And okay, this one was the one of the project we made in a robotic society. So this was a leap motion controlled vehicle. So you see, I am just controlling this using my gesture. So all these things are the applications of the AI. So in this, we are doing a 3D mod. We are rendering the fingers hand. It is recognizing that how I am using the hand. Like I am is my fist is open or not. Okay. So these are the basic things that we are using to implement the AI. So since our first and second year, we were doing this. So was the BCI, brain control wheelchair, which me and Utkarsh made in our first year, like in start of the college only. So we were taking the biosignal of electroencephalogram, EEG, as our input, and I'm controlling the chair using my using the twitching or my blinking, or you can just we are reading the alpha beta and alpha beta waves. We can also read the alpha beta waves of the brain. Okay, so we will using the sensor, and what we did was is we made a algorithm to run this chair, and this Utkarsh contribution was a major thing in this project. So these are the basic thing which we motivate us to make the things happen. Okay, so why I am sharing you with this is because we all, while reading something and while studying something, we should always know the motive, that why we are doing this and how our society will be benefited. And I hope that after this session, you all have uh, you all go with the one project idea also. Okay. So now let's see one application that a GAN can do is. So okay, can you tell me that how this thing the like okay, just listen that. So do you know who is he or who is she? Anyone? Okay. And how this is made possible. So you all know about the Reface app, okay? Okay, Will Smith. Yeah, okay. So this was done by the AI. Okay. Yeah, good. Okay, so this was done by the AI. And have you heard about Reface app? Do you know something about Reface app, that we do the face swapping? Okay, so that is also one of the application of GANs. Okay, so this was done by the GAN, and so today we are going to do this, and I hope that I will be able to make you a small gist. What I will be sharing, I will share you the small algorithms and the basic algorithms of the GANs, and I will be sharing the good resources, and we will be also doing a hands-on. So like this thing you are going to do in this session only, but not in a on this level, but on a basic level, we are going to do this by hand and mathematically also. So I don't want to make this session a bit boring one, so that's why I already show you the applications, that how projects you can build on. So have you I just want to ask that, have you built any innovative project that you want to share with other audience or with me? And Utkarsh is also here. Any innovative project you want to discuss, you made in your IoT in third year or in final year?
Yes, anybody can unmute. Only one student at a time can unmute. But yes. Who is going to? You can raise the hand. Better way. Yeah, so that we can unmute you. Yes, Madhusudan. Yes, you can continue. Yeah. So he's next to me. You can ask the. You can share your experience, Madhusudan.
Hello, I'm audible. Hello.
Yeah, you are audible. Yeah, you are
Uh,
audible.
so mostly working with Uzgare sir, we are working on a few things recently. So we just started with a few more students. We are also
Yeah.
working with using image processing for something like blood group detection, as well,
Okay.
with working with Uzgare sir, as well as just general stuff which is covered in our practicals. So like we can work on image restoration with autoencoders, stuff like that, which covers our practicals.
Okay. Great thing. And first of all, congratulations for for sharing this, and you are working on this. So yeah, these are the projects which motivate us to do this something for the society. And today we are going to see a new architecture called as GAN, and like he already shared that he's working on the blood cancer. So so the answer is generative adversarial network. So today we are, for the next 10 to 20 minutes, we are going to deep dive into this network, and I will be taking every small step. Like, we are not going to use any library or something. We are going to see this mathematically, visually. Okay. So before starting with the GANs, first of all, I would like to introduce with the inventor of the GAN. This is Ian Goodfellow. He is right now, he was in 2009 he joined Apple as director of machine learning, and he was also associated with the Google and OpenAI DeepMind. So he was one of the person who majorly contributed in the Google Maps. So the you see the conversion of street view to the map view, that was done by Mr. Goodfellow. Okay. So right now he's not associated with Apple. So just uh, 1 month back, he left the Apple. Okay. So he was the one. Okay. So the the founding story of the GAN was to interest is can explore on the net also, and I must say that these guys have done a great job. Okay, so let's talk about generative adversarial network. So I hope you are comfortable with me. You are good to go. Any small query? Nothing. Or you all guys are here now.
Yeah.
Just
Yeah.
right, yes. So can I can see that my audience is a bit interactive one. Okay. Okay. So let's start with the generative adversarial networks. Okay. So let me start with a general idea. Okay. So you see there are the two architectures. What just take a copy and take a pen, take a small note or take a pen and write each and everything, because I have jot down each and every point in a very crisp manner. Okay. So all you need to do is whenever you go for any kind of interview or any kind of research project, what the thing is, just need to keep these small things in your mind, how we are how these things are working. So just first of all, we are going to see a two, like we are starting with the black box thing. Okay, you just need to see two things. First is generator, and then is discriminator. You don't need to don't worry if you don't know some anything about generator or discriminator. Just see that this is this generator and this is discriminator. Okay. So okay, so just take the note of these two things. We are going to work on these two things. Okay, so now let's start. So now let's see that what is generator and what is discriminator. So okay, so what the thing is, like, take the generator at initially, just take the generator as a thief and take discriminator as police. So what the scenario here is, the thief has stole something from some painting, and what the thing he's doing is he's confronting the discriminator, the police. Okay. So okay, so the police, the thief will show this that he stole this picture, but actually he stole the good Mona Lisa picture, but he's not showing that he made his own picture, and he's just showing to police that this was the picture I made. So he's the police, and he's asking that is this a picture? And what the generator will like thief will show, like he show this picture to the discriminator, which is our police, and police will say no, this is not the right picture. So that what the thief has done is he made it more clear. So now the police inspector is asking, he is asking from the policeman, is it good? And police inspector is also saying no, that this is also not the good picture. Okay. So next, he has showed the light picture. He's made the perfect drawing. He's not giving the original picture. He's just showing the picture he made from some artist or from any source. So he's showing this picture, and the discriminator got then the police proved that yes, that this painting is correct. Okay. So what the thing is, here the thief learned each and every process and how to draw a good image. Okay. So this is how generator and discriminator, basic example of discriminator and generator works. Okay. So what the generator do is he try to learn. First he try to he will make a small sample. He will learn to do better and better and better. And what the discriminator will check is whether it is real or fake. So just keep in these 2 points very important points in mind, that what generator will do is generator will generate the fake images or the later real images uh, to train himself. He trained to make the output better and better. And discriminator will do is what he will do is he will verify that. Okay. So just take these 2 points in mind. We are coming to we are going depth in step by step. Okay. So is there any doubt that all are with me now? Is it clear to you, like basic like thief and police case?
Yes, student, you can reply
Okay.
in the chat box. Yeah.
Yeah, just write yes. Like we are not taking more than 10 seconds in checking the answers. Okay. Okay. So this was a small case I shared with you. Okay. Now let's convert discriminator and police and thief case into generator and discriminator. Okay. So what my is real images, as someone told you that we use the label data set. Okay. For example, if I took the real images, so what I will be doing is I will pass this to my architecture and I will pass to the discriminator. Okay. So this picture is transferred to my discriminator, and my generator some using some random values transferred random discriminator definitely know that this is not the correct thing. So same the thief and the police scenario. Okay. We are transferring the fake image to the discriminator, and it is verifying because it already know about the original image. Police should have gone through the original image also. So it is verifying that. Okay. Just keep this thing in mind. Okay. Now again, I real image is put to this, so police got to know more about the real image. Okay. Now again, thief has given them the hand drawn picture, and then a good picture, and then a more good picture, and then the perfect picture. And this is what the correct. So what the thing gone here is the generator has learned to or the thief, we can say, has learned to train himself so that he can make the picture better, the output better, more and more better. Okay. So you see, these are the two neural networks which are working. These are the basic cases of generator and discriminator. So just keep this thief and police case in mind, because even if when you give some kind of interview or anywhere else, when you you explain this thing to you. So these are the basic example that you can use. Okay. So itna samajh mein aaya? So have you got this thing? Okay. Okay. Are you? I hope that I am not bored, not making you bored. Okay. Okay. So now let's make a simple GAN. Okay. It's taking these two scenario only. We are going to make a GAN in simple manner. Okay. So let's say there is a different universe where people where a person stand in this manner, in a slanted manner. Okay. So and they have all the screens in that world is of a 2x2 screens. Like I don't have too much colored picture screen. Like representation of the things go by 2x2 only. Okay. So and one layer neural network. Let's take these three things. So you know about, I think you already know about neural networks. Okay. You know about neural networks? Okay, you guys worked on the CNNs. Okay, yeah, that's great. Okay, so for example, let's take a universe where we have slanted people. They stand in a slanted manner, and we have a 2x2 screens. Like we are representing the data, the faces in 2x2 screens. We are a one layer neural network. Okay, so let's take these are the faces. And as I told you that you may have heard about GAN generating faces. So we are going to do the basic theory of that. Okay, so you said, see the Will Smith face, that was a generated one. The architecture generated that face. That point should be clear to you. Okay, is that thing clear? So these are the four faces I am taking. So what I am going to do is, what we are going to do now is, we are going to train a GAN which will generate these faces, these basic faces. Okay, and I have 2 by 2 screens. Okay, so do you think that these four images are representing the tilted face? These four binary patterns are representing the face, or these four patterns are representing the face. Okay, now let me make it more clear to you. Okay, so for example, just we have taken the two binary patterns. So these binary pattern representing the slanted face, and this is the noise, and this is a random thing which we don't know what is that. What is this? Okay, so okay, so let's take these are the, and do you think that these are the faces in that parallel universe or something? Okay, have you got that these are the face? You see that my faces in this word are tilted in a slanted manner, and this I am showing in a binary pattern. You see the intensity of these two blocks. These diagonal blocks are more than these two blocks. Okay, so that's why I'm representing the faces using these two blocks. Okay, so everyone clear with this? We are taking a bit simple example, I think. Okay, okay, that's great. That's great. Perfect. Okay, so now, and this is the random noises. Okay, so what we are doing is we are taking the intensity of white and black from 0 to 1. Okay, so 0.75, 0.75, 1, 1. These are the blocks which are representing the faces and that word, and these are the random noises. And that is not representing the face, any kind of face, because you see the pattern also. If you see these faces, these are slanted manner, and these are the faces which are intensifying that, like in a binary manner. We are depicting that in a binary manner. And because the if the we are considering a block as a face, if the diagonal blocks is of more intensity than these two. Okay, okay, so let's make a discriminator. And so discriminator here that was the police. So the discriminator should verify that this is the face or not. Okay, so let's take the two things, faces and noise. So my face, you can see, are you clear with this? You must have clear with this. This is a face and this is a random noise generated. Okay, so what my discriminator will do, this is like that these two, the discriminator should check that these two diagonal blocks should have a big intensity than these two diagonal blocks. Okay, so this is the basic thing. Okay, and noise can be any. Okay, so to clarify, to verify a binary pattern as a discriminator, we are taking that these two elements are as the big values than these two values. Okay, okay, right side slanted values. Okay, okay, so if I want to depict both these things into a number. Okay, for example, I would like to represent these things as a number. What I will do is I will add these 2 points and I will subtract these 2 points. Same thing I will do in the noise also, in a random thing. Okay, for example, if I am trying to generate a random face using that, so what I will do is I will add these things. I will add these two diagonal and I will subtract these two diagonal. So okay, so for example, the sum of every this thing is 2 and this thing is 0.5. So for example, if I'm taking a threshold as 1, so which will be the face? If taking with the value which is giving threshold more than 1, we are taking that as a face, and less than 1, they're taking it as noise. Okay, so this is the one of the basic tasks which this discriminator will do here. Okay, so is this thing clear with everyone? I think we are not going to in too much complex. Okay, okay, great, great, great. Anyone having any doubt till here? Step by step, we are going to more deeper into neural networks. Okay, okay. So now let's take the next thing. So okay, now let's build a basic neural network. Like I have made a basic neurons using this, and I am just transferring my each and every block to the neuron. Like this thing we do in the normal multi-layer perceptron also, and we are adding the bias. Okay, so and these are my weights. For example, these are my predefined weights, and later we will be randomizing that. Okay, yes. So let's see. So you all know about the activation function, sigmoid activation function, 10H, ReLU. Anyone? I even know about activation function. Okay, that's great. That's great. Okay. So for example, I am taking same thing what I did in 2 slides back. Same thing I'm doing here also. I am multiplying my each and binary digit with the weight, and I am passing it with the activation function. So I'm passing the activation function using the sigmoid activation function, and I'm getting the value, normalized value. Okay. Okay. So 0.73 is my value which I'm getting. Okay. So this is my activation function. Also, these are the values which I'm passing through as basic discriminator neuron. Okay. And now this is a random, like these are the random, these are the values which we are taking. Okay. So yeah, these are the values which is a 0.37. Okay. So can you tell me that is this a phase or not? Can you tell me this should be considered as phase or not? Anyone? Is this a phase or not? You see, my threshold is less than one, and there I set the threshold as one. So my threshold share is less than 1 here, or you can say 0.5. Okay, yeah. Okay, Tejas, yeah. Okay, not a slanted face. Okay, good. So this is not a slanted face. So what we are trying to now discriminator understood, like we first what did we did was we transferred a real image of face to the discriminator, and later we transferred a noise to the rendered discriminator. So now it is able to discriminate between a noise and a original one. Now then let's make the thief part, that how generator will work here. Okay, so as usual, I am taking the faces. Okay, so what I will do here is I would use one random number to generate my noise. So here at the start, what we see was a thief, and now thief here is a generator. So what the thief will do is at the start he will make a random picture of Mona Lisa. So here also our thief here is generator. So generator will make a random image of the face. Okay, for example, if I've taken any random value between 0 and 1, so I am transferring to the same architecture. I am transferring through the neurons, and I am getting one block. So can you say that is this a face or not? Is this a face or not? Like you can see direct, like a visual only. Like these are the big values, these are the smaller one and all. Okay, yeah. Okay, yeah. So this should be taken as the face. Okay, so this will be verified by the generator. Okay, so now let's talk about the error function. Okay, so my generator has generated one face using the training part. Okay, so now let me tell you that how the training process is going on, how generator will train. Like we have seen that it is generating one random thing. Okay, so now let's think we are going to take is the training process, how the training thing is going on. Now, so these are the most two important points I'm going to take, is which you should remember whole of your life while doing the GAN. And the basic idea of the GAN is using its error function and error function only. Okay, so now let's talk about the error function, how the training process go on. So in neural network, we use the error function. We take the derivatives to to minimize the error. Okay, so okay, so these are the one important points. Yeah. Okay. So for example, if my error, if my label, my labeled is one. For example, just forget everything and just focus here. If my label is my prediction is 0.1, my error is large. If my label is 1 and prediction is 0.9, my error is small. That is the simple case we take on. Okay. So what the log error function we take is we take the prediction logarithm of prediction value is the error function here. Okay, so if we take the ln value, okay, so logarithm value of the prediction as the error function here. Okay, I now step by step I will make it more clear to you. Okay, so let's take the log error. Just remember that log function of the again we always take as log of the prediction, log of the output. Okay, yeah. So now what the training process, what we do is back propagation. Okay. So what we are going to do is we are going to predict the error, and we are using the log function only. Okay. So what basically we do is we use the gradient descent to minimize the error. You all have heard about gradient descent and back propagation. You know about gradient descent and back propagation? Okay, that's great. That's great. Okay, now let's take two scenarios. Okay, so now let's visualize the discriminator and generator in a same slide only. Okay, so for example, what my generator doing is my generator is generating a random number. It generated one block. Like this block is generated by uh, yeah. Okay, so this is the real phase data. Okay, so for example, this I am taking as a real phase data, and the error what I want is 0. Okay, and now let me make it just a minute. Yeah, okay. So let's see this thing. So what discriminator is going to do is, for example, if I what my I will train the discriminator in this manner, like it should not take the input as a predicted one, as the true one. Okay, so for example, there are the two cases. I'm just my that slide is missing. Just let wait, yeah. Okay, yeah. Okay, so just remember one thing. Okay, whenever we want to our output here output to be 0, like negative output, we will take our error function as 1 minus output of the like see that d is my error, d is my function from the discriminator, and d is my function from the generator. So for example, if I want 0 as my output, 0 as my error, for example, let's see this thing back. Okay, so for example, I want to label 0 as my label 1 as my true output and 0 as my negative output. Okay, so for example, if I'm taking 0, that this image should be I want to take this 0 as my output, because discriminator should know what is the fake data and what is the real data. So to get the fake data, I want 0. Okay, so my error function should be negative of my prediction, negative of my predicted value, 1 minus negative of my log of 1 minus of my predicted value by the generator. Okay, so what my discriminator, for example, take the discriminator as a police. So police should be trained in a manner that it should have verified that that the sample given to me is fake one. Okay, so for fake one, I my for fake one my output should be negative. So I want be I my just take the label final output label as 0, because I want to get the fake aspect of my input. Okay, so for example, if I'm taking the fake as a true value, so I want the 0 thing. 0 is fake here and 1 is true value here. So I want to train my discriminator in a manner that it recognize the fake it recognize the fake image also. So when we take the fake image, we use the error function as this negative of log 1 minus output by the output of the predicted value. Okay, so this thing clear to you, like this discriminator part, only the discriminator part, and why we are taking 0 here. So this is one of the important point. Okay, yeah, everyone please say yes if anyone having doubt, please raise your hand. Okay, I think we are good to go. Okay, so what am I? Discriminator is my police, and I will train my police such that it should get the fake aspect also. So what I will taking here is I am taking the 0 as my true value. So what I will do is I will take the 1 minus a negative of my prediction from the generator. Okay, so what my generator want to do is this is my thief, and what my thief is trying to do is trying to real data. It's trying to make the real image. So whenever we're trying to make the real image, I will take the error function as negative of logarithm of prediction value. Okay, prediction. So these are the two aspects. So just take the gist as what is the basic concept that good fellow wants to convey here is just train a discriminator in a manner that it can analyze and recognize the fake data, and generator and same side generator will try to make the real data. So for the real data, for the training, whenever we do the back propagate and whenever we train to do this, we always take the output as 1. So this is the kind of unsupervised thing. So coming to the loss function, and which is one of the major aspect in training and the back propagation, we take error in discriminator as negative of log n of 1 minus the output by the generator prediction, and in generator we take the error as negative of logarithm as the predicted value of the generator. So I think these, just remember these 2 points. Okay, these are the one of the two important aspect, and even at the last you can ask about your doubts too. Okay, so I think we are good to go here. Everyone is clear with this thing. Yeah. Okay. Okay, so that's great. Now let's come to the training part. So for example, yeah, let's visualize everything which we studied till here. Like I'm taking the real image, I'm passing it through the discriminator. These are my weights. Okay, the same thing like generator will do here is it will try to generate an image, like a slanted image, and which will be verified by the discriminator, and later. Okay, so these are my prediction values. Like you see, after doing that, this for the discriminator, this is my original data, this is my face, and these are my simple basic neural network activation function, and the basic multiplication we do in artificial intelligence backpropagation. We are multiplying each and every input to the associated weight, and after that we are passing it to through the activation function. And for the discriminator, okay, for the discriminator we are taking the error function. Yeah, error function and 1 minus of dx, and this x value will be with this x value. This is my x value, and this was the output by my discriminator, or you can say the real data. Okay, and yeah. So these are the basic calculation which we do in back propagation also. So whenever we in this part by taking the derivative, we take the error function as 1 minus d of x1 into xi. Okay, so these are this input can be from the generator also and from the real image also. Okay, so the log error function you see here, we are taking the final thing is from the noise. Noise is from the GAN data. Okay. Okay. So whenever I take the input as my real image. For example, if I'm training with the real data, I will be taking the error function in which I want the output as my 1. Okay. So I want to train the discriminator as a truth for the true label. So I will be taking the log function as negative of log of d of x, which is my real image. And if I want to take from the noise here is generated by the discriminator, by the taken by the discriminator is from the generator. So this is the noise is from my generator part, which is randomly taken from the generator, and the error function which I will be using here is 1 minus of d of x. Okay, which is my prediction. Okay, so yeah, same thing is with the generator also. What we are doing is we are taking the negative of dg no, discriminator input, discriminator function. So negative of log of discriminator function. Okay, so yeah, these are the calculations for the generator thing, and you can also later you can also do in your personal laptops also. So these are the basic implementation and the calculation. These are similar to the backpropagation and the training process only we do in your normal neural networks. Okay, so just the main just I want to show you is the loss function. Okay, the basic idea of the loss function which we are using here. Okay, so what I did here is I have made the same thing in a particular collab notebook. I have made a particular collab notebook for you guys so that we can implement the data like one binary hands-on data which you can try on your particular laptops also. So I'm dropping a link in the chat box, so you can implement each and every scenario of this thing in your own laptops also. So just try it. Just click on the connect and open this in your Gmail mail IDs and click on the connect. And what you need to do is you just need to simply run these codes. And what I did is I've explained everything in a formatted manner. Okay, so you see, let's do it by some kind of code. So if you guys are able to open this Google Colab notebook, please indicate in the chat box. Okay, okay, that's great. Okay. So just click Shift and Enter to run any cell. Just click Shift and Enter to run any cell. And what you will see here is this is the one of the plotting function. What this function is doing is generating a random faces. Okay, so for example, if I want to make the slanted faces, example of slanted for other, these are my sample slanted faces which I have simple generated using the array data. So you can see these kinds of faces which we are generating, a simple binary faces which we are generating. So is it working? Okay, that's great. So just see my screen, please. Okay, so what we are doing here is these are my generated faces. For example, these are my true images. So what I'm going to do there is, and these are the random images. So these are the faces which will be which will be taken by my distributor, which is my police. And these are the images which will be taken by the generator, which is my thief. So we are training the discriminator from the noise and the real image both. Okay, so now let's take a basic sigmoid function, which this is the part, the discriminator, which I was talking. So loss function from the images. So these are for these images. The loss function which we are using is this, and for the noise images, which we want to train them as a negative value. So I want to train my discriminator that yes, this is not the correct output I want. So what my output was 0. So what I will do is I will just make it a negative 1 minus my predicted value. So for in this manner, I have made a discriminator here. So this is a discriminator function. So you can see each and every equation in a mathematical manner also. So what the good aspect of this code we can see here is I'm not using any kind of library, predefined library like PyTorch or TensorFlow, which you guys work on, because that library from that library we get the modules directly. Okay, so what we are doing is we are doing direct mathematical calculations to make the generator, and using this you can train your own color images also. Okay, so these are the derivative weights, update from image, error from noise. So these are the simple like you see np.log function we are using to take the error from the noise, and to take the error from the image we are taking the negative of log of prediction. So this, you see, these are simple basic mathematical calculations which we are trying to implement on the GAN. Okay, no library or no library function. These are the simple mathematical functions we are going to do. Okay, so now let's make a class of a generator. Okay, so this is the class for the generator. So you see what my generator here is. My generator, the loss function which I am using is negative of log of function negative of log of prediction of my generator under the function of discriminator. Okay, so you see these are my derivatives, same class, same the thing we made the class of a generator discriminator, we are also making of generator. Okay, so you see, these are this is the error function which I have defined. Okay, so you see the output which my generator is taking from the discriminator. You see, this is one of the important line of the code. The error function, this thing, like in the error function, we are taking for the error function, we are training the generator from whether it is verified or by the discriminator or not. So just let's take it as an example. For example, this is my thief. So my thief had made some kind of drawing. So thief is my generator. My thief and generator made some kind of drawing. Now who will verify that? Who will verify that? My discriminator and my police is already trained with the real data. So what my generator will do here is it will verify its output from the output given by the generator. This is my thief. My thief have made some kind of noisy random image. Now we want to verify. We want to train our neural network as per this drawing. So what I will take the help of my discriminator. The thief will ask the police whether it is correct or not. So that's why we are taking the output of the discriminator. First we are training the discriminator, then we are taking the output of for discriminator to train our generator, to train our thief. So here our thief is getting trained by the output of my generator. Same thing what we are doing in the class also. We are for the error function, we are taking the output of our discriminator to check the error function. Okay, so this is one of the most basic code you will see of GAN architecture is this. Okay, now whenever you will code in any and for any big data set, you will use the libraries also only. Okay, so for example, I have implemented the class also. I have implemented the training epochs. So yeah, so these are my basic error generator, error function, discriminator, error function. So now let's generate some kind of images. So you see, using this training, using epochs, like for example, I have epochs around 1000 basic epochs, and learning day 0.01 I used to for the training function, and these are my generated images. So you see now what my generator was given as the input was these kinds of images, random generated images. And now how my generator is generating the images are the proper faces. So you see, these are the output by the generator. Okay, I thrown some random noise. Z is my random number, and I had thrown it to my generator. G is my generator. Generator dot forward is my random number. So now see, even after inputting the random noise, I am generating a proper face because my generator is trained with the using the help of the discriminator. Okay, so you see, my thief is now trained with the proper Mona Lisa image. Okay, so these are the weight. You can visualize that this thing in the weights also. These are the particular weights, the final weights which our neural network is trained on. So this is one of the most simple code of the discriminator generator example you will see. So if you talk about face generation, like a real face image generation of the cell face data, I have also given the code of that. So here what we are using is what we are implementing is the MNIST data. So we are generating the number. So this is the basic MNIST data sample set I'm using. So in this we are using the PyTorch library for the generative. So you see, there we coded in a very basic manner, but the same concept is using to work on the large data set also. For example, if this code is doing is it generating numbers from the lambda values. Okay, so here also we have made one generator module using the uh, convolutional module, convolution filter, and we have made a discriminator module. So same thing we are working in a big manner. So you see, whenever you try to implement something whenever you're trying to implement in a code or in something or doing something, just take the mathematical gist also. So read the mathematical equations, how the background thing is working. Don't just directly go with the libraries and the predefined architecture. See that what is happening at the background, how basic things are worked on. So you can compare each and every class of this code with the predefined one. So here what you did is you did everything mathematically, and here we are using function. So in the mathematical documentation, you will get to know the gist that my this normalization is working, how my forward layer is working, dense net is wo- how my dense layer is working, how am I flattening the thing, and how which activation function, why activation function I am using, and how my error module is going on. So you see, these are the basic two classes. Same thing we did in previous code, we are also doing here. So just try whenever after this session, just try to compare these two code, and you will get to know that how my real library and my industrial code working with my basic mathematical and basic mathematical code. So after, I'm not going to train this right now because it will take much time. So just whenever you try to train this, not just change runtime to GPU. Just take this hardware layer as hardware accelerator as GPU. So these are the same process which we did for the slanted faces. So here what my generator is generating are the numbers. Okay, I'm just giving them a random lambda value, and I'm getting a proper random generator. So there are the n number of GAN applicants. So for example, Utkarsh is using I have made a GAN for the data generation. So just if you are having a less data set, and if you want to make the more data set, for example, any kind of cancer, if you are using less histopathology images, and if you want to create more histopathology images from the data, you can use the GAN because it will generate using the train thing. So same code you can use there also. Okay. Okay, so yeah, this was the hands-on thing, and these are the particular resources which I'm sharing with you. So these are the very important resources, which are like one of the three most important resources of the GAN. So
Okay.
you just if you are
Yeah.
hello,
Yes, yes,
yeah,
yes.
yeah. So
We,
if
we
you
do
are
one thing. We do one thing. If you
yeah,
could share this presentation, then probably I will share the resources with the student.
Yeah, sure, sir, sure. I will be sharing. I will be sharing in few minutes. So these are
Okay.
the few resources which I am sharing with you. So these are the resources by the given by the inventor only. So this is one of the PPT and the slide which is we had which is which will make you clear each and every concept of the GAN architecture. So just and GAN before reading going for the generative adversarial network, just take the lecture of the given by the Stanford University, and this was the PPT which was given by Ian Goodfellow, who was the inventor. So these are the it contains the each and every small aspect, and you will see that we are doing the same thing. We just did the same thing only. Okay. So yeah, okay. This was all from my side with the GAN. I hope you have some kind of small doubts. We can take 5 minutes, and after that, Utkarsh will take on with the research and opportunities and where you can apply research. So, someone have any doubt, he can unmute themselves and ask me.
Yes, students, you can unmute yourself and ask. Otherwise, you can post your problem in the chat box. That's also fine.
Yeah.
I think, Rishabh sir, we will take the all the questions towards the end. So
Okay.
student
Okay.
will
No.
prepare. I just
Oh,
urge the student, you prepare your questions and we will ask them one by one. You just post it in the chat box. We'll take towards the end of this session. Is it fine, sir?
oh. Yeah. Yeah. Yeah, sure. Sure. Sure.
Because
Sure. Sure.
most of the students they are joining this session from the mobile, so maybe
Okay.
they
Okay.
will take time to write the problem. Okay.
Yeah. Okay.
So thank
Utkarsh.
you.
Yeah. Utkarsh, are you there? Yeah. You can take on.
Hello. Yeah, Rishabh, can you just present the slide?
Yes. It's visible. Utkarsh, it's visible. Yeah. You can continue. You are audible and your video is not visible actually.
Yeah, I'll not switch on my video because the bandwidth is not good
Bandwidth.
right now.
Okay, no problem.
Okay.
Absolutely. Yeah. You can
Yeah.
continue.
So, whatever you learned right now, you have to like apply it somewhere else, right? So, there are like many good opportunities in this field because deep learning is like having a really good impact in all of the domains. Rishabh, can you go to the next slide? Yeah. So, how can you like become how can you come in this field? So most of the people are, so first I'll clear you about the roles. There are some people who are named as software developers, and those of them you call as SDEs. There are some people who work on data to analyze the data, you call them data analysts. There are some people who work with the science behind all those data and try to model them, they are called data scientists. There are some people who work with machine learning and deep learning aspect of it, or more or less you call them machine learning engineers or deep learning engineers. So that's how all the roles are specific to each and every person, and you can see what is important for whom by this graph here itself. The PPT will be shared to you. Rishabh, next slide. Yeah, so the previous one was related to the industrial experience, and if you want to like go to become a machine learning expert, so basically machine learning is programming probability and statistics in some form, or modeling probability and statistics. So basically what you have to do is first have some hands-on knowledge, or like first have a strong fundamentals of probability and statistics. After that you need to be proficient with various machine learning and deep learning modeling techniques. So you can go on doing some courses online, which are available on Udemy as well as Coursera. So those are some of the ways you can proceed in this manner. After that, one of the most important thing is you need to develop some kind of projects in this specific field so that you can go on to get an internship or a job. So, and apart from that, like once you get any kind of once you get any kind of project that is like having some kind of impact, you can go, you should like have some industrial knowledge as well, because the ones you read in theory, it is completely different from what you have to apply in industry. So doing internship in this domain is really important to have a career in this field. So apart from that, like, this was the industrial aspect of it. So how can you go on developing projects? You can participate in hackathons. Like some years back, there were really less number of hackathons, but now you can see there are like huge number of hackathons that are being organized. Hackathon gives you a chance to brainstorm yourself on some of the ideas, and you can go on and develop a project on these domains. And if you get a prize, that improves your profile as well, adds up a project in your CV, and like you can pursue that project further also. So to develop a project, one of the best things you can do is by participating in hackathons. Yeah, so most of the hackathons and projects have been already discussed by Nitin sir. So Rishabh, can you go to the next slide? Yeah, so as I said, after developing your projects, doing internship is really important. If you want to work with a startup, AngelList is the best way to go, right? And if you want to like apply online, you can go on applying on LinkedIn. You can search for jobs online, and there are various internship positions available where you can go and apply for that. Or you can just directly mail any person in the research domain or the industry domain that you want to work with them. You have those kind of previous research experiences, and like you want to do internship or gain any kind of project experience in that field. um, for example, like in my case, I previously this summer I went to Washington University, US. So I did my research internship with Mallinckrodt Radiology School, that is ranked number 1 in advanced cancer imaging and advanced cancer sciences. So um, you have to like so previously I have like 3 accepted research papers, 2 applied patents, and 2 of the research papers like are under peer review right now. So you have to work on research projects as well. Once you start doing any kind of research project, you can go on to develop that specific profile, and you can mention that in your mail that we that this is my previous experience, and I want to work on this domain with you. And that's how like you get any kind of internship. So that is like really important. So either you can go on doing industrial internship or research internship. Both are really different. Industrial really deals with business strategies or the business requirements of customers, while the research internship requires you to think beyond what other people can even think of. So that is how like you can go on to these fields. Yeah, so I think the session would like go much bigger. If I go in depth, we can take up questions, and in that way it would be much better.
Yes. Now I would request all the students. Thank you, first of all. Thank you, Utkarsh sir. Um, I think we'll take the questions from the students now. Yeah, students, please raise your hand so we can go one by one. See, don't feel shy. Your question may be stupid question, but ask it. We'll just give you a minute to just write your problems in the chat box, or you can raise the hand. No problem. Okay, I just wanted to ask the Utkarsh sir and Rishabh sir, both of you. I mean, how you have motivated to do your career in the AI ML? Yes, sir. Rishabh sir, your mic is muted. You are not audible.
Okay, okay. Sorry. Yeah. That is Utkarsh, would you like to take this? I can analyze the questions.
Yeah, you can go on, Rishabh.
Yeah. So basically, our motivation was like we both started the this thing in our first year only. So we have a kind of a similar interest. So like the peer group is one of the most important thing, one of the most important thing in our domain. So we learn this thing from each and every from each other. Like I like since my first year, I wanted to do something for my society, and I want to implement my theories and my practical thing directly to the user. So I found AI is one of the best way to implement this and to make this make the society impact using our learning. So yeah, in AI you make the projects which are related to medical domain also. AI is a very vast field. You get the gist of the medical domain. You get the gist of the, like, there are many things. For example, e-commerce also, NLP, machine learning, computer vision. So AI is one of the fastest growing field right now, and every company is expecting data science as in their team. So it's also good domain in placement also and related to research also. So this was one of the major motivation for that. Yeah, thank you, sir.
Thank you, thank you, thank you. Over to Utkarsh sir. I just wanted your experience. I mean, because we know that today's scenario, everybody is rushing to computer science and IT, right? And everybody wants good packages of 12 lakh, 24 lakhs per annum, and so on. I mean, you could also get that, but you have chosen this field, research. Why? Utkarsh sir, over to you.
Yeah, so I'll just like to clear one thing. There is like what I feel is uh, people are rushing towards computer science. It is not that bad thing because the situation of the world is increasing. The people who initially have to do manual things now have to upskill themselves with the computer related things. And now the people would much become like the maintainers of these automated things. So there is not like learning computer science is a bad thing. Computer learning going towards this domain is really really important during this time because everything is going to be automated in like in near future. So that is one of the important things. And running towards like what you said are the packages. There is a good side of it. There is a bad side of it also. Uh, because just there is only one thing which you don't have to do is getting inside your comfort zone. Once you start getting 80,000 salary inside your bank account, then there is some kind of problem. Like you'll do the same thing throughout your life. But if you like enjoy your thing, then like running behind, there is no problem running behind the money because like we are the founders of Oculus Private Limited, and being a business, we know like we know
Yeah.
that how much important money is.
Yes.
So why we chose research is because from my childhood I like doing research really like a lot. I like to know the background of each and everything and how that thing is working from behind, and if I can do something to like change them. And my research is usually focused on having a societal impact. Whatever you are doing should have us, there are like lakhs of problems available in front of you. For example, I'll give an example of lumpy skin disease. Nobody is able to solve that through a proper channel. We have like monkeypox, we have we recently the COVID came, and the whole world was using artificial intelligence to design a drug. And you have various problems like medical problems or like societal problems, or like people are getting depressed. How do you detect they are depressed? So I think the list is endless. So that's what keep me motivated to do all those things. Even my startup, we are developing devices to help uh, blind individuals or visually impaired individuals to navigate around, and that is like already been incubated from IIM Bangalore. We have received incubation from Canada. We have received incubation from CM Startup. We have been a part of Startup. We have been a part of Shark Tank India, the very first season, and we were like the finalists also in that. So that's all the thing. And apart from that, like recently I went to um, US, like Washington University. The research there is completely different from what you see here in India. What they do uh, is they focus on things from the base, uh, or they have a kind of disciplinary research. You don't have to think research from only one domain like computer science. For example, my research was on segmenting CT scan images. So that has not yet been done using unsupervised method. So I was there designing the algorithms for that. We got some kind of good results, but uh, the research environment you get there is like completely different. So in the end, the two most important things that you need to consider is you have to be self motivated on whatever you are doing. You are getting a degree, just prove that, right? Just if you are having a BTech, just prove your BTech degree. Try to solve a Try to solve any kind of societal problems, or anything which you like. It's not only the societal problems. Apart from that, be self motivated. There is like no one who is going to tell you that you have to do this to earn this much, you have to do this to like do that. That is what these are two important things.
Yeah. Thank you, Rishabh. Thank you, Utkarsh sir. Utkarsh sir, there is one question. We have only 5 minutes left. So there is one question that is there any optimizer good as compared to Adam? I mean, is there any best optimizer as compared to Adam?
There is no best optimizer in my case, because even I used Adam optimizers in one of the cases. it it totally depends upon what kind of problem you are having. For example, if a problem can be solved with a simple if else condition, then you don't need to go towards an Adam optimizer. You can do it with simple stochastic gradient as well, because in my case the performance was being degraded using like the Adam optimizer, so I had to introduce a momentum based stochastic gradient descent optimizer. So uh, what I would suggest is every optimizer is having a different use case. Just read about why that optimizer came into existence, so that is like important.
And I've also shared one repository with you related to research, various research internships. So apply in that, make the research papers, and apply in companies internships. You will find in the LinkedIn we shared you the sources also. And don't think in this manner that you will not earn money after doing AI. Like in my case only, like Pharmacy, all the unicorns in India, Pharmacy, Zomato, and these Ola, these kind of companies are hiring data scientists. So you can message them on LinkedIn. They will definitely reply you. I got the placement in I got the in my internship and my PPO in pharmacy using the LinkedIn only. So there I was in the e-commerce. So everyone is hiring data scientists. So data scientists, you maybe you will learn more about you will earn more than a SD in data science domain. So definitely like 20 lakhs, 23 lakhs, 25 lakhs package and 14, 15 lakhs in your college only. There will be a not a big challenge for you. So if you guys make a good research paper, and they always in our interviews in data science, they always ask you about your researches, so your research and your projects. So even if your DSA is not that much too good, your CP is not on the grand level or 4 star 5 star, and you have good projects and good basic data structure skills from the lead code only, and kind of research and some kind of one or two research paper, then it will be more than enough and to crack any interview. Yeah, so I will also shared you the opportunities also, so country wise.
Okay. Uh, I hope there are no questions, no more questions in the chat box. Okay, if you want to Ask question, you can unmute the mic. No problem. Unmute your mic and ask. Otherwise, we're just leading towards the conclusion of this session. Is there any question? No? Okay. So it's my we are coming towards an end. Uh, so it is my great privilege to propose a vote of thanks. I would like to express my sincere thanks to both the experts, Mr. Rishabh Dhinkawat and Mr. Utkarsh Chaurasia sir. I would like to extend my gratitude to the management, principal, vice principal for their consistent support, encouragement, and big thanks to all the students who have joined here. And I'm very much thankful again to the today's speaker, Utkarsh sir and Rishabh sir. You have brought the insights of deep learning. I hope out of these 70 students who have attended, at least 20 or 25 students will be motivated, and they realizes that yes, this is the field that they want to do their career in future. Thanks a lot for your precious time. I know your lot of research activities are going on. You are very tight in schedule, but still, in spite of your busy schedule, you have took the time for our students. I'm really thankful to both of you. Thanks a lot
Thank you,
once
sir.
again.
Thank you, sir.
Thanks.
And
With this,
one more thing. Yeah.
yeah, yeah.
Can I?
Continue, sir.
Actually, I will be sharing one feedback form with you. I hope that you can you give some feedback, even if it's good or bad. Just write it in the feedback form. It will be a good help for us for the coming sessions. Yeah.
Yeah, definitely. You just post your link in the chat box.
Yeah.
I will copy it and I will paste it on our WhatsApp group as well, the class groups. Okay, sir, you just
Yeah.
paste the your feedback link, because even I'm going to share the feedback, but
Sure. Sure.
that's
So I'm sharing the link with you.
yeah.